Hi, welcome to LeetCode. In this we will discuss LeetCode problem 3434, maximum frequency after Subarray operation. So the problem shows that you are given an array nums of length n. You are also given an integer k. So you perform the following operation on nums only once. Okay, only once. So select a subarray. So like subarray from index I to j, nums of I to j. Select an integer x and add x to all the elements in nums of I to j. So find the maximum frequency of the value k after the operation. So we have to maximize the frequency of k in the nums. Now how actually we can increase the frequency? We can actually select any subarray. Then actually we can change this number because they mentioned that we can actually select any integer x and we can add x to all the number. So ultimately, suppose we actually have 2, 2, 3, 4 and our k is equal to suppose 3. Now what we'll do, suppose we selected this subarray as a subarray, we want to try to maximize the frequency of k. So what we'll do, we will actually count the maximum frequency, which number actually this subarray, suppose there are a remaining number also in the left hand side and the right hand side. So what we'll do, we already know whatever the k actually present, that we will not change. Okay, k1 and k2. Now whatever subarray actually we have selected, that we will check which number actually present maximum times, like which number actually have the maximum frequency. That number, if we change this to k, then actually we will get the, like we already know k1 plus suppose x in this subarray and k2. This is constant in the input array, and if we actually increase the x or the number of k in this subarray, then actually ultimately our total frequency of k will be increased, right? So what we'll do, we'll choose that number that is present maximum times in this subarray, that subarray actually we choose. We will convert that number into k. Like here actually what is which number actually present maximum times? Here actually presents k is equal to 2. K is equal to means like 2 is present twice. So and 3 and 4 is present only once each. So frequency of 2 is greater. So if we convert 2 to 3 or k, then actually we will get this, suppose k1, and here actually 2, 3 and 3 will be changed to, 3 will be changed to which number? Because here actually we are adding plus 1, so 3 will be changed to 4 and 4 will be changed to 5, and this will be actually k2, right? K2 will be here present. So got it? So how actually are increasing? Like here actually the total number of k will be k1 plus here actually 2 and k2. Previously it was only 1, 3 actually present. If we don't do that operation, right? Now it is increasing by 1 because previously it was 1, only 3 is present, only 1. But actually 2 times 3 actually I can actually convert this. But in this actually we can actually optimize this. We can actually convert it, get the target. So what is our brute force approach? Brute force approach is that we will select all subarray, all possible subarray. Okay. Then actually we will actually count the which number actually present maximum times in this subarray. Okay. Then I will convert that number into k. Got it? So suppose I got that maximum frequency is x. Okay, that number will be changed to k, and whatever actually k is present in the remaining in array, that will be a constant, like here actually k1 and here actually k2. So our end for this number of k will be, if I apply the operation only on this subarray only, then our number of frequency of k is k1 plus x plus k2. In this actually we will actually check all the possible subarray, and actually we will take the maximum value, whatever the maximum sum actually I can get, that will be our answer ultimately. Suppose for this example 1, 2, 3, 4, 5, 6. So our target is k is equal to 1. So first of all check all possible subarray. So 1, 2, 3, 4, 5, 6. So all possible subarray, 1 is 1, then 1, 2, then 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, 6. This is one possible subarray. In this way 2, 2, 3, 2, 3, 4, 2, 3, 4, 5, then 2, 3, 4, 5, 6, 3, 3, 4, 3, 5, 3, 4, 5, 3, 4, 5, 6. In this actually I will check. So now we all know what is the total number of k present. Total number of k in the input array present. K is equal to 1. So I have seen 1. Only 1, right? So I have taken this subarray, and what is the maximum frequency here actually is only 1. So I'll convert this. I don't need to convert this because this is already 1. Okay, if I convert this into k, okay, but remaining k will be 1 plus 0 because I have already consumed 1 here. Okay, 1k here. So that's why this will be 1 is the in this subarray that actually I can actually convert, and the remaining whatever the actually array is remaining, that is the 0. K present 0 times. For this subarray I choose 1, 2. So in the remaining subarray, how many actually k are present? I have consumed on one here. So remaining will be 0, and I can convert this for the maximum frequency here actually 1. So I can convert 2 to 1 or 1 to 1. Any one of these actually I can choose. So this will consume 1. So again it will be 1, 1, 2, 3. In this way it will actually in the remaining array the number of k is present 0, and in this subarray the maximum frequency is 1. So I can choose that to convert to k. So in this actually I will choose that. Now here actually I got all 1. Okay, for this subarray what I will do, in the remaining array how many k are present? 1, because I have not consumed any 1 here. So that's why the total array input is number of k present 1. So in the remaining are also present 1. So what is the maximum frequency here? 2. So 2 will be converted to, I can convert this 2 into k is equal to 1. So I can get 2. So this is our current maximum. So if I check all the possible in this way, I will get the 2 as a maximum value. Got it? So you can see that our answer is 2. Got it? So in this way, brute force, this how many time considerable will be. So to generate all possible subarray, time considerable will be big of n square to generate all possible subarray, because it's starting from I to j. So I will be 0 to n minus 1, and j will be also 0 to n minus 1, or I to n minus 1, any one of this. So this will be big of n square, because for each I will choose I to n minus 1, right? So I into j means there are 2 for loop, so this will be n square. Got it? Now for each subarray I have to iterate once to get the frequency of what is the maximum frequency, right? So this will be actually big of n square. If I optimize this, then it will be possible to achieve only once, like whenever we are iterating, shifting the right pointer of the subarray, ending of the subarray, then actually we can count the frequency of the current number, and then actually we take the maximum frequency at the end. So we don't need to do this, so I can actually optimize this, but still it will take n square time, right? Now how can I optimize this? So first of all, let's see some observation, then it will be easy to understand. So here actually k is equal to 1. So ultimately in brute force approach, what are we doing? We are actually choosing one subarray that actually contributing maximum number of k if we convert this. So when actually I choose this subarray, like for this example, this is the next example. Suppose what actually subarray actually can choose total number of k actually I have seen in the input array 1, 2, 3. Initially 3 k are already present. Now if I choose this subarray suppose 2, 2. So how many times it will contribute this subarray? 2. So our answer will be 3 plus 2, 1 is 5, right? Now, so this is the maximum 5, but if I choose whole subarray, this 2 to still 2, then what will be the actually I can actually get? So here actually 4 2 will be converted to k. 4 2 will be converted to k. K is equal to 1, because here maximum frequency is 4. And the remaining how many actually k are present? 1 here and 1 here, so 2. So this is we are getting 6. So how are we actually getting this? So when I am choosing this subarray, we are actually seeing that maximum frequency, whatever the actually number actually have, minus number of k already present. present in this subarray. Correct? So you can see that here actually in this subarray maximum frequency is 4, right? And how many k actually I will lose if I actually convert this 2 to k? I will actually lose only 1. So I am actually losing 1, right? 1k, because if I convert 2 to 1, then 3 will be changed to something else, 1 will be changed to something else, right? So 3 will not contributing anything before and after changes, so there is no contribution for 3. But 1, it was previously contributing a total input array, but now as I am changing in this subarray, that's why now it is actually losing, contributing it will be less, so that's why it will be actually lose 1. We will lose 1. So that's why you can check that we're actually getting what? 4 minus 1, we are getting 3, right? Maximum frequency 4 and we are losing 1k, so that's why we are actually getting 3 ultimately. So 3, if I do 3 plus, how many total k actually are present? 3, 6, we are getting 6. Got it? So you got it, right? So this is the one clear, this explanation is clear. Example, like we are actually getting 4k after transferring 2 to 1 or 2 to k, and we are losing 1k, so that's why we are actually ultimately getting 3. Got it? And from this remaining how many actually total input actually k actually I have seen 3, so 3 plus 3 total 6. So you can actually check one mathematical expression, then it will be more clear. So initially we have k number of k, okay, suppose k1. So now I have changed this subarray, this green subarray. So in the remaining part, how many actually, suppose here actually we have k2 input, k times k2 times k in this subarray that we are going to change. So what will be the remaining will be k1 minus k2 in the remaining space, in this space and in this space, in the space 1 and 3, and in the 2 what we'll do, we will, this is the remaining space, we will actually have this, and remaining space will be maximum frequency of number that actually get. So this will actually, what actually we can do, so we can actually write get k plus k1 is constant, because we can actually at the input actually can calculate this k1, how many actually times k is present in the input array, and we can write this as maximum frequency of the number that is present in the subarray minus k2. Got it? This is actually the subarray that we are going to choose. This is clear? K1, this is k1 minus k2. What actually ultimate being? We will actually lose this k2 times k, and we will actually get maximum frequency that is present that many times k ultimately. So that's why I am just subtracting k1 minus k2 that is present. K1 minus k2 actually indicate the how many k are actually present in the remaining space. Remaining space means 1 and 2 space 1 and 2, that is present k1 minus k2 times k. And what actually I will get the maximum frequency that is present in this space 2, right? Clear? Now if I k1 is constant, we can actually calculate this at the initially. And what I will do, if I adjust this operation, this minus k2 with maximum frequency of number, then actually we get the, that I have to maximize this value actually ultimately. If I maximize this value, then actually I can get the answer, maximum frequency of k. Got it? We have to maximize this ultimately, this thing, maximum frequency of the number, that if that is the greater than the k2, the number we are losing, then actually we can actually convert this. Otherwise we do not need to convert this subarray, right? We only convert if we are losing only 1k but we are getting 2k, then actually we are actually getting profitable, right? Then actually convertible is important. Clear? So suppose for this example again, so if I choose this subarray, okay, this 2 to 2, so how many actually we will lose? We will lose 3k, because this will be converted to another number, this will be converted to another number, right? And we will actually gain will be what? Maximum frequency is 2, 2, 2. So maximum frequency is 3 again. So the gain will be also 3. So ultimately what actually the gain is 0. So you need to convert this. Got it? Okay, but we choose another Subarray, this 2 to 2. What actually we will lose? We will lose only 1k. This will be converted to another number. And what will be the gain? Gain will be 2. This 2 and this, what is the maximum frequency here? 2. So this 2 will be converted to k. So that time gain will be 2. So ultimately what is the gaining? We are gain is plus 1, positive 1. So that time actually this is actually, we can actually convert this. Got it? It is clear? So we will choose that what is the maximum frequency it is present in the current Subarray minus the k that which we are losing in this Subarray. So what we will do, we can actually, here actual range is limited 1 to 50. So we will try to convert 1 to k, then 2 to k, all the possibility, 3 to k in this way, 50 to k. Okay, now suppose I want to convert 3 to k. Okay, now so 3 will be contributed as positive 1, it will be gained by 1. If we see any 3 in the Subarray, so it will be contributed as a positive 1. And if we have seen any k that will in the Subarray, so that will actually, we will lose that. So that's why this will contribute as minus 1. And else like 4 or 5, that will be actually not contributing before and after also. So that's why else it will contribute as 0. Clear? Plus 1 when you are trying to, this is the, suppose I want to convert this, suppose 3 to k, all the 3s to k. Now if I see any 3 in the Subarray, then 3 will be contributed as positive 1 and k will be minus 1, because we are losing that. Previously it was k, it was contributing in the initially, but now we are converting this 3 to other numbers, so this will be also converted to another number, else it will be 0. These 3 condition is clear. Now how actually we can actually get the answers. Suppose for this input array 1 2 1 2 1 1 2 1 2 1 2 1 2 3 1 1 2 3 1. Now suppose I want to convert 2 to k. Here k is equal to suppose 1. Okay, so first of all calculate how many times k actually I have seen. K I have seen 1 2 3 4 5. Correct? Initially actually I have 5. Now I want to convert all 2 to k. I will try. So what I will do, I have seen here actually 1. So ultimately this actually previously contributing. Now it is actually, we will lose that. Now it is 2. So 2 will be now contribute, because we are trying to convert 2 to k. 1 also we are losing it. This one also will lose. This 2 I will gain that. This one will be minus 1. This 2 will be plus 1 and 3 will be 0 and my 1 will be, now it will be lose. Now if we take the maximum Subarray sum, that actually give us the like maximum contribution I can actually get. So here actually this is minus 1. We will not take this Subarray in the part of the Subarray. We will not start from here. We will try to start from here. So here is a plus 1. So I will actually convert this 2 to k. So this is minus 1. Again our contribution is 0. So we will not take this, because we have seen maximum contribution 1. Why we will convert this both together? Ultimately we are not gaining anything. So what will convert this? Okay, this is minus 1. So this is minus 1. We will not actually starting from here. We actually end it here. Okay, because if we start from here, we are actually losing thing, right? So that's why we will not actually discard this Subarray. Got it? What is the logic? That if we start from this plus 1, we are actually losing 2k, but we are gaining only 1k. That actually a loss. So that's why we will not take this Subarray. So we will discard this. Now again we start. So this is plus 1. We will actually start from here. So before we have seen 1, positive 1. So that's why this is actually a current maximum answer. Again it is minus 1. So this will again we will lose. So this is ultimately 0. So this is 1. So we will convert this. We will take this, right? So this is 0. So ultimately this is 1. Here actually losing thing. So this will be ultimately 0, again 0. So what is the maximum gain actually I can take? I can take only 1. Got it? It is clear? So what is the answer will be 5 plus 1. So k I have seen 5 and maximum I have seen 1. This is clear? Why actually getting 1 here? Like you can see that we're actually 1, but we're actually choose, if I suppose start from here, we're actually losing 1k. That will be adjusted to our current answer. Got it? What actually I have seen? Maximum frequency of that number minus the number of k actually I have seen in this current subarray. That I have to maximize this. So here actually maximized value is 1. Got it? So if I add this expression is clear. I got 1 here, maximum frequency minus the number of k we are losing. Here actually you can see that maximum frequency here actually is 2 and we are losing 1k. So 2 minus 1, we are losing 1. So this is clear. And the total number of k actually I have seen initially, that is 5. So this expression now it is clear. This mathematical expression that k1 plus this expression k1 plus maximum frequency of the number minus k2 that I have consumed here. Got it? Actually getting this answer, this expression, if it is clear, then it will be easy to code also. If understood, please like the explanation. If you have any doubt, you can comment on that also. And if you not subscribe, please subscribe channel. Now go to the actual code. So first of all, I have taken a map to count the frequency of each number. Okay, and map k also give the value of the k I have seen in the initially, right? Map k. So in the map k, here actually map k will be 1. So 1 will be in the map, 1 will actually contain 5. Value will be 5, right? So now how to do? I will try, if our current number is not equal to k, so I will try to convert all the number from current 2 to k, 3 to k, 1 to k in this way, right? So if our current number is not k, so I will try to convert that number to k. So first of all, I am calling this algorithm Kadane algorithm. So here actually what we'll do, we will choose the which number I am trying to convert to k, and k is the target which number actually I have to convert. So I already explained that if I here actually the number I am trying to convert, and k is the which number I have to convert, which number I have to, the target number that we are trying to convert. So in the current number, if we see any the current in the num set, if you see any b means which number we are trying to convert. If it is that number actually present, that will contribute as a positive one, right? So that's why I will increase the current plus plus. Initially current is equal to 0. And if the current number that actually present in the num series, that actually k, then that will lose that number will be lose. So that's why that time I will decrease the current value by 1, current minus, else the remaining number will contribute to 0. So that's why I have not done anything. Okay, now take the maximum sum. Maximum sum means the maximum subarray sum actually we can get. Got it? And the current will be 0, maximum value of 0 or current, because if we get any negative, so we will discard that subarray, because that actually we are losing thing. So that why you have to start that from starting that subarray. Start from next. Try to start from the next. Here actually the example is clear. Like here actually you are losing thing. Here actually minus 1. If we take this subarray 2, 1, 1, so here actually we will lose 2k, but we are gain only 1k. 2 will be converted to 1, but 1 will be converted to something else. So that we are losing 2k, but we are getting only 1. So why to lose that? It's better to don't apply the operation, right? So that's why I will choose that if that is negative, then try to discard the previous subarray and try to start from the next index. So that's why maximum value is 0. Take the maximum value 0 or the current number. If it is already positive, then try to maximize that. If it is negative, then discard. Okay, and ultimately return the maximum sum I have seen. Got it? So in this actually I have store the maximum frequency. Maximum frequency means this value I have stored. I have actually stored this thing, maximum frequency minus k. Okay, now I will do what? Ultimately map of k, this is constant, and whatever the maximum value I have seen, that I will return. Suppose this is x, so that I will return map of k plus x. Got it? The mathematical expression, how it is working here, I think it's easy to understand now. So ultimately at the end, whatever the actual answer actually I've seen, I will add this with the map of k. Got it? I have shared this code in the description box. You can follow that. Thank you.